What do you think of when you hear the words mixtape? Now, for most of you watching, a mixtape probably means just that, a cassette tape that somebody sat around recording tracks onto to give to somebody else. And now that I finally have half decent equipment to make one, that's exactly what I did. And of course, this is going to go to the missus. But there's no point in giving her a mixtape without something to play it on. So that brings me to the subject of today's video. This thing. It is a National Panasonic boombox from the mid-80s, the RX-F2 FA to be exact. This came from eBay some months ago, and I kind of just put it aside. I didn't really think about it too much, but I noticed the missus was eyeing this particular boombox off, so I thought maybe we should get it cleaned up, restored, and that will make something that'll pair nicely with the mixtape itself. So let's check this thing out, see what's up with it. It is a bit dusty and grimy, but I'm sure all of that will clean up. What I'm more concerned about is the condition of the cassette deck itself. So let's just throw in a tape. Obviously, I'm not going to throw in the mixtape because it's got a bunch of, well, soppy, lovey-dovey songs for the most part, and also I don't want to get a copyright strike. So instead, we're going to rely on a tape full of the jazz from the YouTube audio library. Of course, just like any good boombox, this has an AC input along with a separate DC input, and of course there's space for 6 batteries. We're just going to power it off the AC for now. Hopefully it doesn't explode or anything. Well, it's plugged in and it hasn't exploded, so that's a good sign. Let's take a quick tour around this thing. So we've got our volume and balance controls. There is also a tone control, a selector switch to go between the radio and the tape player, obviously the tape transport buttons. We've got selections for FM, medium wave, or AM if you prefer, shortwave 1 and shortwave 2, and then there's a mode switch to go between ambience, stereo, and FM mono. It spruiks being able to run off AC or battery, and obviously we've got our little tuning dial display up here along with a couple of lights. Around on the side, pretty standard, there's just a main tuning dial, and then there's a little fine tuning knob down here which feels very loose. And of course in the front we've got the tape player mechanism itself. And if I push play we can see that the take-up reel is turning, and it's not stopping easily, so that's always a good sign. It means the belts are at least doing some work. Rewind works, fast forward looks to work, so it looks to be functional. Does it sound any good? Well, that's another story. Let's find out. So, I've thrown in the YouTube jazz tape. Ah, we have music. Balance control works, even though you won't be able to tell because I'm only wearing a mono microphone. The tone control, which goes between bass and treble, really is just a treble control. So if you turn it down towards bass, everything just sounds muffled. And of course, going up towards treble, everything sounds a lot brighter. Doesn't sound too bad though. I do hear a little bit of wah and flutter, so the piano notes there sound a little bit wobbly. Let's do a quick comparison with this tape in another deck, see how it sounds on a half decent deck compared to this little boombox. Because this thing only has a headphone output, there's no line outputs, I've just set the volume, balance and tone control to their mid position. That should give us a pretty decent idea from a direct capture what this thing actually sounds like playing back a tape. So I can definitely hear there's some high frequency roll off on this thing, and that could be the azimuth is just out of alignment. It could also be that this tone control just needs to be boosted up a little bit. So I've got a couple of test tapes that we're going to use today. One of them is a 10 kilohertz azimuth alignment tape, and the other one is a 3150 hertz speed and one flutter test tape. I've briefly shown these on the channel before, so I'll put a link to the website where you can find these tapes yourself. But it is from a guy in Germany, so the website is partially in German, I think, as are some of the descriptions on these tapes. But it shouldn't be too hard to work out what tape is for what, and you know, there's always Google Translate. So let's take a look, see what the wah and flutter on this thing is like first, see if it's still within spec or if it's terribly out. I imagine it's not going to be great by this point in time, but maybe some new belts will remedy that. So to do the wah and flutter test, I've just got this connected to a capture device which goes to the computer, and we're just using the WFGUI software. So there's a couple of figures of interest here. One of them is the frequency, which is around 3200 hertz. That should say 3150 if it's playing back the tape at the correct speed. So it's running a little bit too fast. The other one is the wah and flutter figure, which is a percentage RMS figure, and we're looking at around 0.17% on average. It's sort of jumping around quite a bit. That's not really a huge surprise for an old 80s boombox like this, but I think we can improve on those figures. And if we do so, then the playback of, you know, especially sustained notes isn't going to sound so wobbly. And just for fun, let's have a look at the azimuth. What I'm going to use for this is actually an oscilloscope, because it's just a little bit easier to view on a scope. I think there are software programs that you can do similar to the wah and flutter test, but I prefer an oscilloscope for this one. I haven't actually looked into software programs to do this test, so I don't even know what to suggest. But if you've got a 2-channel scope on hand, this is quite simple. Just going to hook our audio inputs into the scope and hit play on the azimuth test. These two traces should be aligned with each other. So I like to use the trace pattern for this. Some people prefer a Lissajous pattern to do this test, but I like the trace because we can easily see that both traces are out of phase, but their intensity is fairly similar. So their actual amplitude is similar. It's just that they're shifted out of phase. But I'm not going to worry about adjusting the azimuth. I'll do that last. First thing I want to do is get this thing open, clean it out, and probably replace those belts. So it looks like we have multiple screws in the back. Let's just start pulling them out, see if it opens up. And no doubt there's one in the battery cover. Yes, there is. Now, will we have to take off some knobs? Quite possibly. Tight little buggers. Oh, there's movement. Aha! Right, well, at least we've got a good view of the cassette mechanism. And yeah, it doesn't look too bad. The heads look fairly clean. Pintroller could probably use a clean, but it's not too bad. We'll get to that. First thing I want to do is get to the back of this so we can access the belts. So it looks like we've got a screw here. And one down here. Is that enough? Yep, it is. I just have to get it out from under this board here. Haha. Cool, there we go. It actually looks somewhat familiar. So this is the mechanism from a Commodore 64 dataset, and yeah, the similarities are definitely there. Very close. One thing I do know is the Commodore 64 dataset uses a belt size of 80 millimeters, so that's likely what this one is going to be as well. That's good because I've got plenty of those on hand. So removing that screw and removing this screw on the side over here should allow us to free that belt. So there's a little slot in this metal part that the belt slips through. A little trick with these is you can actually bend this metal piece outwards. It doesn't affect the functionality of the deck itself, but it allows you to easily swap belts should you ever need to swap it again in the future, because you don't have to take those screws out. The belt will just slide out under this bent up metal piece. But while we've got this metal part off, we may as well just clean these grooves around the flywheel and this part here, and of course the motor as well. I might actually, the motor is soldered in, but I might actually just desolder this just so I can give this a good proper clean out, because it's caked in dust as well. That's a little bit better. I didn't want to disturb any of the grease that's in here because it still seems to be greasy. Now I'm just going to go through with a bit of IPA on a pointy cotton tip and just get right down in those grooves. Make sure they're nice and clean. Ugh. Alrighty, let's get a new belt. So I think these should be an 80 by 1.2. Let's just compare these. Try not to confuse them. Looks about right. And the thickness when I lay them both flat on the bench is exactly the same. So yes, this is the correct belt. One little tip is to not cheap out on your belts. These ones I got from Wagner in Australia, but I've also ordered some from fixyouraudio.com, not sponsored by any of these people by the way, and I've found their belts are much better than those junk belts that you get in those little multi-packs from China. They will give you serious wow and flutter and speed issues, and I found that out the hard way when I was trying to repair a Sherwood deck that I showed on the channel a few months back. The reason I got massive wow and flutter figures from that is because I was using cheap ass belts, and when I changed to good belts, those figures went down considerably. I think with the cheap belts it was around 0.5% wow and flutter, and with a good belt I actually got it down to around 0.1%. Unfortunately the decks in those things also self-destructed. I think they were stuck in a weird state and the motor tried to turn the cam gear the wrong way and broke off some more of those little plastic pegs, and at that point I basically gave up on that deck. Thankfully I do have another half decent deck which is a Kenwood from the mid-90s, and that's actually what I used to create these tapes, so it does a pretty good job with recording. Anyway, back to this one. So rather than put the belt on now, I'm actually going to reinstall the screws on this thing. And because we've bent this little tab up, I can just slip the belt straight in there. Cool, that should be it. Everything is turning as it should. Excellent. Let's give these heads a clean and this pinch roller. So just some more IPA for these things. Alright, that looks much better. Generally I don't worry about replacing the pinch roller unless it's like cracked or it's got an indent from being pushed up against the capstan. The pinch roller can obviously affect the wow and flutter, but I've found a bad capstan drive belt is the biggest factor when it comes to wow and flutter. The pinch roller is fairly minimal unless it's really messed up. In terms of lubrication, I'm not going to worry about replacing any of this grease. Everything still seems to slide in and out properly, so I don't see any issues there. So yeah, I think this deck should be good to go. Now while I've got all this apart, I am just going to pull out the rest of this stuff. I might check a few of these caps. I don't think they're going to be bad, but it'd be nice to be able to get all of this out and then I can properly clean up this case. Alright, so I may have got a little bit carried away with the disassembly, but at least it'll allow me to clean everything properly and I get to reassemble it. It'll be just like working on the assembly line. Maybe not. All right, let's take a closer look at these boards. I guess we'll start off with the power supply because it's very simple. Little bridge rectifier circuit here. Obviously this big thing must be a transformer, and yes, it does say danger primary. So primary side goes in here, secondary side looks to come out here, but interesting that it's all sealed up in this metal can. Apart from that, there's not much to it, although, well, that's a bit of a worry. There should be a fuse here, and instead we've got a piece of wire. It doesn't look like that's been done after the fact. I think that was done, could have been done during manufacture. I think we need to put a proper fuse in there. I mean, that little bit of wire will act as a fuse if you put enough current through it, but that's going to take a lot more current than this thing needs. So first things first, let's get rid of that wire, put a proper fuse in. That's dodgy, can't have that. Check through the little box of fusey bits. Oh yep, I've got a couple of fuse holders. And that'll fit perfect. Oh, there's our old fuse. All right, let's get a proper fuse in here. They specified a 1 amp on the board. They just didn't bother installing one, apparently. Here we go, 1 amp fuse. That's better. Okay, with only about, what, 10 components on this thing, and one of them was already dodgy, it's not looking good. Let's see what we've got here. So the main thing I'm going to be worried about is these electrolytic caps, and straight away, if we look under this one, there's some green nasty stuff around the leg on that cap, so not off to a good start. Yeah, there's more right in the middle there. Look at that leg there. Green nasty stuff. Well, I mean, there's a number of caps, there's not too many, and thankfully they're all mostly small value, so probably easier just to replace all of them. All right, all our electrolytic caps are out of the board. I decided to just take them all out in one hit and just make notes of where each one of them goes back in. So hopefully I don't mix that up. But yeah, as you can see, I've got the old caps up here and then replacement caps here. A couple of these I don't have replacements for. The 0.1, 0.22 and 0.33 microfarads I don't have replacement electrolytics for. So I'm going to put in MLCC or multi-layer ceramic caps in there. Hopefully that's okay. I don't actually know. It's probably not that important really, not for a boombox like this. But everything else I pretty much had. I did have to salvage all of these, which are all 1 microfarad caps. This side over here has all the leaky caps, so no surprise, they're all very similar. There's 247 microfarad, 210 microfarad, and all of these 100 microfarad, and then a couple of 220s, and this 1000 microfarad looks a little bit iffy. So these are all the bad ones, the obviously leaking ones, and these ones are just questionable, but given that maybe half the caps in this thing are leaking, I think it's best just to replace all of them. Obviously I didn't plan on doing a recap job on this thing when I first started, but here we are. In fact, while I've got the meter out, let me just show you. Let's have a look at one of these 100 microfarad 10 volt caps, the ones that are obviously leaking. So capacitance, they test right around 89 microfarads with an ESR of 2 ohms. But if we compare that to what's going back in there, 93 microfarads with an ESR of 0.3 ohms. So yeah, these are definitely on the way out and need to be replaced. So I'll get to work on that, and we'll come back when all the replacement caps are in. All right, all our fresh new caps are in, so we can throw all these away. And I've also gone around and cleaned up all the plastic bits and everything else, so it's finally time to put all this back together. Alright, and we're pretty much reassembled. The good news is that I don't have any screws left over, so that's always a bonus. Or I've got the ones for the front of the case, but we'll get to that. I think it's best just to power this on now, just to make sure that I got all those capacitors in the right way and nothing explodes. Alright, let's see. Oh, well, it's live. The radio's on. Does the tape deck still work? Looks like it does. Okay, that's good. It's very much in the left speaker, but yeah, that's just the balance. All right, cool. It seems like this thing still works, so let's put this front cover back on and see if we've made any improvements to the tape deck itself. Cool, it is reassembled. Obviously I went through and cleaned it. It does have a slight bit of yellowing. I think this is supposed to be like a cream color, and yeah, it is slightly yellowed, but probably not enough to worry about retro brighting it, I don't think. So now's probably a good time to adjust the azimuth. Thankfully they did leave a little hole to access the azimuth screw in here, so that shouldn't be an issue. Although the front cover might cause a problem. Should be able to just throw the tape in like that. All right, looking on the bench scope, it does look like both channels are in phase, so they peak and dip at the same points pretty much, but they may actually be 360 degrees out of phase. So the good thing about having the scope set up like this, as opposed to a Lissajous pattern, is we can see if the amplitude changes when we start turning this azimuth screw. So you can see everything drops quite substantially going that way. And that looks pretty good. And then if we keep going, so it looks like everything is correct there, but it's actually 360 degrees out of phase. So if we go back to this point here, that's actually the correct azimuth. So we have maximum amplitude and both channels are in phase with each other. So that's actually what we want to see. All right, I'm happy with the look of that. Let's check out the one flutter, see if we managed to improve that as well. All right, we'll throw in our one flutter test tape. And we have 1.6, 1.9, 1.5, 1.8. So it's actually not really any different to before. It's average around 1.6 maybe. So the tiniest improvement, but I did hope for something a bit better. In saying that, once I saw the mechanism was the same as the one in like a Commodore dataset, I didn't expect too much. Well, the speed is almost close. It's 3174. We want that to say 3150. And I did spot a hole on the back here that should go through to the motor speed adjustment. So with any luck, I've got a screwdriver that'll reach. Well, I don't know where that hole is supposed to be, but I'm not finding it with the screwdriver. It sounds like I'm just hitting the motor itself. I guess I'll have to open this thing up again. Damn it. Knew I shouldn't have put all the screws back in. Okay, and now that I look at this again, the hole for the speed adjustment is actually on this side of the motor. So why they give you a hole at the back of this thing with a little curved arrow around it, I don't know. But we definitely need to do it from this side. Anyway, let's throw our tape in. Plug this back into power. And we can hit play. I probably should just, oh, it's still reading about the same, 3170. I mean, it's pretty close, probably don't really need to adjust it, but while we're doing all this, may as well. Oh. And it's very easy to go too far. That'll do, 3148. It's not like anyone is going to ever notice the difference between a couple of hertz, but it's nice to have things properly calibrated sometimes. I didn't bother putting any contact cleaner into these pots. They don't seem to be scratchy, and I think they have some kind of grease in them, so I don't want to disturb that. Let's close this back up, I think for the last time. All right, the last thing to do is test out our YouTube Jazz tape, see if it sounds any better. I imagine it's going to sound a little bit better in terms of high frequency response, but in terms of wah and flutter, it's probably going to be pretty much the same from what we've seen. So definitely an improvement with high frequency response. The wah and flutter, yeah, it's pretty much the same, and I can't really expect too much more from a deck like this, but I think it has turned out looking pretty good. Definitely a good cleanup has certainly helped, and it looks, well, apart from some slight yellowing, close to new. There's a few scratches here and there, but overall I'm satisfied with how this has turned out. I did also spend just a little bit of time listening to the mixtape that I made, and through this thing it actually sounds pretty good, like better than some of the other boom boxes that I've heard. So yeah, I'm pretty happy with this thing. So hopefully the missus is happy with it too, but well, I guess that remains to be seen. Anyway, I think that's it for this one. So a huge thanks to the people that support the channel on Patreon. If you want to do the same, links to that are down in the video description. You'll get ad-free early access to all videos. And yeah, apart from that, be sure to like, subscribe, blah, blah, blah. That is it. I will catch you in the next one. Bye.